talking about number 7 now, right?
Um, number 6, when it says X, it's saying X bar, right? That little.
Yeah.
Okay. It's like a capitalized X bar.
Yeah.
Describing X bar decreases as the sample size increases. Yeah, I'm going with you on that.
Okay.
We have like 3 different recordings for today's session, so I wonder which one actually took, because we got kicked out last time and it doesn't always save the recording if you're kicked out.
Oh, really?
I actually have to save it, but
Ugh.
whatever. He'll see that we met and we've obviously been meeting for a while.
Yeah.
Okay, number 7. Let me read it a second.
Okay.
You know what? I'm glad number 6 is actually in here, because it's occurring to me that I need to go with flashcards and like quiz myself on the difference meaning between central limit theorem and law of large numbers.
Yeah.
I'm writing that down. Make flashcards.
This is...
Because next time you and I meet, I'll be able to tell you the difference. That's my goal. Okay.
Yeah, for number 7, I've already kind of done 7 and 8. So 7, sorry.
You already did them. Hang on, give me a chance. I need my notes. You already did 8 too?
Yeah, it was when like we got kicked out and I was...
Oh. You were
and
like, I'm going to...
called me. I was just kind of going ahead.
So... Is 7 my turn?
If you want it to be.
I don't remember whose turn it is.
I don't either.
Oh,
Well, I've already done it, so you just tell me what you get and we'll compare answers.
1.0455.
That's what I got.
And then we drop a 5 to be to the 3. Or is it 1.046?
It's probably 1.046. Let me get to my calculator. Oh, I already... Hang on. Mine says 1.0454, so I'm just going to put 1.045.
I apparently did that wrong. Okay. I'm using this as my calculator.
What is it?
I'm using this as my calculator.
Oh, so am I. It's okay.
But it gets like this small. Like this, I don't know if you can see it, but that's like the scientific calculator. So you have to use like really small fingers.
Oh, gotcha.
Okay. Just give me a second to do number 8.
Okay.
Where do we select it? Above 160. And this one we use the probability app again. That's what you did, right?
For number 8?
Yeah.
Yeah.
Let's see. 1. Right. If you put it in the normal probability app, it gives you 0.147 or 148. Or
Mm-hmm.
no, 148.
Yeah, that's what I got.
We have to round it. Okay. Number 9.
Okay, I haven't done number 9 yet. So.
What is the z-score correspondence sample? I wish they'd have a different name and not call everything z-score when it has a different equation.
Uh-huh.
I wish they'd call it something else.
Yeah. There it. Oh, I see. Okay. Oh my goodness.
So with number 9, we just find the mean. We find the mean of the sample, or what?
Well, what I did, I don't know if I'm doing this right at all, but what I did is I took those 5 scores, added them up, and then divided by 5 to get the mean of them.
That's what I was doing. But
Okay.
then I don't know, is that the mean or is that the mean of sample means or whatever?
I think that's the mean of sample means because it's giving you a sample. That's a random sample of 5 students. So I'm guessing that's the mean of sample means.
160 plus 175. When you added them up, did you get 800?
Yes. So then you
And then
divide
so
by 5.
160
Uh-huh.
is the mean of the sample.
Yes.
Sample mean.
So then you have to find the z-score. Well, yeah. So I got an answer, and I want to see if we get the same answer. I want to see if I did it right. Hi, Miss. I'm fine.
Okay. That looks like I'm doing it right. Just a second.
Okay.
Hmm.
What did you get?
Well, I used 5 as the sample, but I'm not sure I'm supposed to do that. Is
Yeah,
there a different sample size?
I wasn't sure either. So did you get 2.338?
Yeah, I did, but that's way too high.
I know that is really high. So maybe we're not supposed to, because if we're not supposed to, we get the exact same answer as number 7.
I'm going to put 2.338 because that's what I got twice.
Okay.
2.338 is what I'm putting. It's really high, but that's what I got.
Okay, so then number 10.
And since you got the same one, I'm going to go with it because I just solved it twice and that's what I got.
Okay.
Because I got 2.3377. That's what I'm going with.
Sounds good to
Number
me.
10. What is the probability 5 randomly selected students will have a mean score that is greater than the mean achieved for the students in the previous problem? So that just means we put that number into the probability app.
Yeah.
It would be the area to the right of the 2.3377,
Yeah.
right?
That's what I did at least.
Then our answer
It says round your answer to 4.
for number 10. Oh, it says to 4? Ah, I'm so glad you're reading. So it'd be 0.0097.
Yeah.
That would be 0.0097. Right?
What? I'm sorry.
You're fine.
Ugh. So yeah, I got 0.0097.
Okay, that's what I put.
Okay. Okay, so number
Round your
11.
answer to 4 decimal places. Done.
Okay.
What is the shape of the 7 distribution? So either it's approximately normal or we can't not determine it.
Oh, goodness. Oh, you're stuck. You're stuck on my shirt. Well, the sample size is pretty big, or the random sample.
So that makes it approximately normal because the sample's so big.
Yeah, that's what I was thinking.
Yeah. Yeah. Number 12, what is the mean of the distribution of the sample means? The mean of the distribution
For all
for all possible samples of size 81 that could be drawn from the parent population. So does that mean we do that same equation and instead of putting in 5, we put in 81, or is this different altogether?
No, because that gives you the z-score when you do that equation. That doesn't give you the mean.
Oh, that's right.
So
That's right. So my textbook.
isn't it just 3.5? Isn't that the mean?
How do we get that?
It's in the,
What they give us?
yeah, they give it to you. Isn't that it?
Because it says, suppose the mean of GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. But then it says, what is the mean of the distribution of the sample means?
Hmm.
because that's the mean, and then the sample's 81. So how do we find the mean of the sample means?
I don't know.
Or the distribution? What is the distribution of the sample means? Sampling distribution. We have to find the mean of the distribution of sampling means.
I feel like we don't have enough information.
Sampling distribution. When is the sample mean normally distributed? Let me see. The parent population is normally distributed. For the mean of draws from a random variable with mean, mu, and standard deviation, the following are true. The mean of the random variable x bar is mu. The standard deviation of the random variable x bar is standard deviation divided by the sample. Maybe that's what we need to do.
So the standard deviation divided by the sample? Is that what you said?
Well, I'm just reading the textbook right now.
Okay.
I don't know that that's what we need, because that one's how you find the standard deviation of the random variable, which is kind of what we want because we want the sampling distribution, right?
Mm-hmm.
Mm-hmm. Hey, we got the other one right.
But, oh, the number 11?
Yep, that one's right, because I just came across one that says almost the exact same thing in the textbook.
Oh, really? Nice.
It says, since the sample size is large, 61, we can conclude the sample mean is normally distributed.
Nice.
Done. We know 11's right.
I just gotta figure out how to do number 12.
I'm trying. I can't.
No, you're fine.
What is the mean of the parent population?
It's 3.5.
Okay, I'm just going to do that. It's not. I think I'm just trying to make it a lot more complicated than it really is. Because it says the mean of the distribution of sample means is the same as the mean of the parent population.
Okay.
So you were right. I was making it too complicated.
No, it's okay. Okay, so 13. So
what is the standard deviation of the sampling distribution of the random variable x bar?
the mean.
That's the standard deviation.
So okay. I really hope, I don't know, this almost seems too easy. You know what I mean? If they just give it to us.
No, I mean we have to find this, because they said standard deviation is 0.7, but I mean we have to find the standard deviation for the variable x bar. So we have to do the equation. So it's standard deviation. It's the one that I just read in the textbook. That's why I was like, oh, that one is the x bar. So what's x bar? That's 81? No. Are we solving for x bar then?
Well, we're solving for standard deviation.
Well, they gave us that one. Hang on, I'm kind of talking. Okay, this one is x bar is standard deviation divided by the square root of the sample size.
But we don't know the standard deviation. We're trying to find the standard deviation.
No, they gave us standard deviation is 0.7,
Oh,
but we're trying to find the. Here, can you see my textbook? Can't tell if you can see it. Hang on, let me get it up to the camera. I can't see my screen. Here we go. All right, I have the equation here. Let me see if I can. Oh, it's backwards.
Oh, I see. No, it's not backwards. I see. Okay.
So it's the x bar is standard deviation divided by the sample mean, and that's how you find the standard deviation of the random variable, which is what we're trying to do.
Okay. And it's the square root of the sample mean, right?
So we put 0.7 divided by 81 squared.
Okay. So squared.
I'm not squared, square root.
Oh, okay.
I can talk. I always say squared when I mean square root. That's not a very good habit.
It's okay. So we round it to 3 decimal places.
7.
So what did you get?
0.078.
Okay. Awesome. Hey, I'm almost done. I'm almost done. What's that? What do you have there? Is that Daddy's scriptures? Let's not play with those. Let's not play with those, okay? What are that? You hide them? There's a book. Let's find you a book. Yeah. Where is your
What is the probability that the mean GPA for 81 randomly selected anyway, no. We only have 2 more, we're almost done.
Yes.
What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? So we just use the probability app, right?
Yes, but where are they getting 3.3 from?
Yeah, it's true. We need to know that if we're going to find the z-score, because we can't.
Unless that's the z-score.
Yeah, but then it's not specifically for the 81 students if we don't have. We can't just plug in 3.3 in the app, because that's going to be clear on the right.
Yeah.
3 point. I'm going to just do it and see what it gets us. And it wants to know less than that. That and that. And then if we put 3.3.
Just a minute. I know, buddy.
That's huge. That would be 0.99995. That's huge. That can't be right.
No.
No, because that's not specific to the 81. That's just 3.3. So we need to solve for the z-score the same way we did before, where we plug in all the numbers we have. Z equals x bar minus mu divided by standard deviation divided by the sample of n. So I can plug in all my numbers.
Okay. What do we put for the x bar, though?
Maybe 3.3? What's it probably? Yeah, because it says the mean for 81 randomly students is they want it to be less than 3.3.
Yeah, that makes sense. Because we're subtracting it from 3.5. And then the standard deviation was...
So we say 3.3 minus 3.5 divided by 0.7 divided by 81 to the square root.
Yeah, that's how I set it up. So let's see. Connor, shh.
Is it just me or does he sound like a panting puppy?
Kind of. I think he's getting restless because I'm not paying attention to him.
Just a second. We only have 2 more questions left and you can have your mom.
Okay, what did you get?
I'm putting it in again because I pushed one of the numbers wrong.
Okay. Oh, Connor, you just messed it up. Okay. Let me try to see.
Negative 2.5714. 2857. So it would be negative 2.571 that we put into the left side. 2.5714. Enter. Yeah, it just drops the 4. So that would be 0.0051 at the top.
What did you get? I'm sorry. 0.0051? Is that what you got?
That's what I got at the top.
Okay.
The area. 0.0051 is what I'm writing down from the applet.
Okay.
And that's when I shaded the left.
Yeah.
Is that what you got when you shaded to the left?
Yeah, that's what I got. But, okay, we rounded to 3 decimal places, though. I'm on the last one. The last one. Do you want my pen? Here. Want it? Oh, you want my notebook? I don't think you can have my notebook. Reader.
But I don't know if that's the answer.
Here. Why wouldn't that be the answer?
I'm just checking. Okay. I just wanted to make sure there wasn't anything else in the question I was missing.
Okay.
0.0051.
You only round it to 3 decimal places, though.
Oh. Okay, so just 0.005.
Last one. What is the probability?
So it's the same thing we just did, but we have to put it in and shade it to the right.
Yeah. So do we
unshade? So I got, when I unshade, what was that number I got? 2.5714. When I shade it to the right, that just gives me the same answer.
Well, do you shade the middle too? Because that's to the right of it.
Oh, yep, you're absolutely right. So, never mind, you're right. 0.9949.
So 0.995. Connor, no, bud. Oh my goodness. Okay, I'm almost done. Ow, that hurt.
Okay, it's my turn to submit.
It's up to you. I can submit first.